Okay. So you can title it Chapter 5 Practice Test. Put your name on it because we're turning it in. This was the Big Ideas version of what your test would look like. A lot of the problems are similar to the test you'll be taking next week. We're taking a test over this on Tuesday. So for those of you wanting to get your IXL extra credit turned in and all that stuff, you have until the end of the day Tuesday, because Wednesday we are starting Chapter 6. So number 1 says solve this system of equations. Go ahead and write those equations down. Y equals 2x plus 6 and y equals negative 2x minus 4. Because these equations are both written in slope-intercept form, if I had a graph, it'd be really easy to graph and see what the intersection is. There is no graph. So what method should we use here, Levi?
Elimination.
We could. What would you do to eliminate?
I would add things, everything together.
Okay.
So then that would be 2y equals 10. And then I could divide.
Sorry. I'm trying to keep up with you, Levi, but I can't because my iPad will not let me. So if you use elimination, you're saying we just add everything together. Now, you'll notice that normally when we do elimination, they're written in standard form, correct? These aren't written in standard form, but everything is lined up like it should be. Like the y's are above the y's, equal sign, x is constant. So if you add them together, you said that you would get 2y.
Yes, 2y equals 2.
Because the x's cancel out. And what does y equal then?
That means that y equals 1.
Okay, excellent. And then if you plug 1 in to, let's just say, the top equation. AJ, do you have a question or an answer? Okay, if you plug 1 into the top equation, what do you get when you move the 6 over to the other side? Okay. And what is negative 5 divided by 2? Good job. So make sure you put them in the right order. The x was negative 2.5. Now you're putting it in parentheses. I'm trying to fit it into this box they have on my screen, but you guys are writing on your paper. So it'd be negative 2.5, comma, 1. My guess, and Levi, you can do that. My guess is most of you probably weren't thinking elimination, and that's okay. I was thinking substitution, but I've taught you 3 different ways to do it. Graphing would work if I had a graph. Elimination does work on this one. If you used substitution,
you just plug the first equation into y.
yes, because they're both already solved for y. 2x plus 6, I just plug it in for the y right there. And we'll solve for x first this way. You only have to write one of them.
Okay.
Harrison?
So if someone says they want to do elimination and you do it up there, can you substitution on this, like on the
Yes. Yeah. You don't have to use, yeah, you could have started and said, I'm just going to do this using substitution. Yeah. You don't need to do the way that I'm doing it here. You can, yeah, I'm just showing you both ways, but from now on, I'm just going to do one and just pick whatever one you want to do. Camden?
So you'll let us choose on the test like between elimination and substitution?
Absolutely.
But will there be ones where we will have to graph it and that's the only thing?
Yes, and it will say solve by graphing. Yeah. Now, you're welcome to check your answer using substitution and get your answer that way, but you are going to get points on whether or not you graph the lines properly. So you will want to solve it. If nothing else, you will want to make sure you've got your lines there too. But yeah, I'm open invitation. If it's a graphing problem and you want to check it using substitution, that's fine by me. Just got to have the lines and I got to see them intersect and all that stuff, or maybe not intersect. It's no solution. If we move the negative 2x over to the other side, it becomes a 4x. If we move the 6 over to the other side, it becomes a negative 6, which combines with the negative 4 to make a negative
2.
Negative 6 and negative 4 make negative 10. And then I'm going to divide by 4 and get a negative 2.5. And then I would plug it in to probably the top equation again and plug negative 2.5 in right there. What do you get when you double negative 2.5? -5. -5 plus 6 is what? So then I get the same answer. Yeah, good. Yeah, I will from now on just do one of these methods for these. Number 2, make sure you're numbering the questions. That was number 1. You just needed to have one of those 2 ways and then your answer. Number 2, select the graph of the system of equations. And so they want us to know which of these 4 represents those 2 equations. One equation has a y-intercept of 3. The other one has a y-intercept of -3. 3, -3, 3, -3, 3, -3, 3, -3. That doesn't eliminate any. So now I need to look at the slopes. One has a y-intercept of 3 and a slope of -5/3. 1, 2, 3, 4, 5. 1, 2, 3. Could be this one. 1, 2, 3, 4, 5. 1, 2, 3. Could be this one. Wait, hold on. 4, 5, 1, 2, 3. Not this one though, because it's supposed to have a negative slope, and this one has a positive slope, so we can rule that one out. We actually use a different color. And down 1, 2, 3, 4, 5, 1. No, they did probably -3/5 on that one instead of -5. So we're down to 2 choices. Check the second one. It needs to have a slope of 1/3. Rise 1, run 3. I think we found it. Yep. The other one has a slope of, sure, you could just put A. You don't need to draw that picture. Yeah, the other one has a slope of 3/1, not 1/3, at least it looks like. So, number 3 wants you to solve this by graphing. Okay, so what I'm going to have you guys do then is not draw, just put no work on your paper, and then you help me graph this. So Madison, Davis, where is the y-intercept on the first equation? Okay. And Madison, where would I find my another point that I could use to graph this line? You got it. 1, -1. Because it says the slope is 3, so we would rise 3 and run 1. And so this is the line I get from the first equation. Okay. Caitlin, what about the second equation? What's its y-intercept? Okay. And where would I find another point on that line? Not 1, -1. You went down 2/1. But it's not a slope of -2. It's -1/2. So down 1/2. Positive 2, 2.
Oh, yeah.
Because if I put it here, I'm making it a positive slope. It's a negative slope. So I want to put that point right there. And that means it's actually going to intersect my graph. So next to where you put no work, go ahead and write the answer down. It should be 2, 2 in parentheses. That is not a straight line. That's like a Camden line there. But I tried to make it straight, so I wouldn't take any points off. Okay. Unless you did something like crazy or something. I don't even know. Number 4. This one specifically says solve using substitution. So we're going to use substitution. The top equation is already solved, if I can underline, it's already solved for y. So we're plugging 6x minus 11 in for y, substituting it into the bottom equation. And so that's going to give us this equation, negative 2x minus 3 parentheses, 6x minus 11 That's where I'm substituting that in for x, and then equals -7. This is the first method we learned in solving systems of equations. Jocelyn, what number, I'll be careful here, what number am I distributing to the parentheses? Good. It is a -3 because the sign in front of the number belongs to that number. If you only distribute a 3, you will get the answer wrong. So Jocelyn, what's -3 times 6? Okay, we'll put the x beside it. And what's -3 times -11? Good. And because it's positive, we'll put a plus sign. And we're just going to copy everything else down. Elise, when I combine my x terms, how many does that give me? Good. -20x. Okay, making progress on this. Remember, substitution is very front-loaded. Getting the work, finding x or finding your first variable takes the longest amount of time, and then finding your second variable will be a piece of cake. George, what do you get when you move the 33 over to the other side? Good, because it's a -33, combines with a -7 to give you -40. Dylan, what do you get when you divide both sides by -20?
2.
Excellent. So we have the first part of our answer, x is 2. And then Dylan, would you plug 2 in for that x on the top equation or that x on the bottom equation? Yeah, it's already solved for y. Dylan, what's 6 times 2?
12.
12. Now show some work for this, even if it's just writing 12 minus 11. Because writing that, when I grade your test, shows me which equation you plugged it into. Okay. If you wanted to even show more work, you could say that you're plugging it in right there. Okay. But that's how you get those extra points. If I can't even tell what equation you're plugging it into and you got it wrong, like I can't even give you partial credit for that part. So Dylan, what is 12 minus 11?
It is 1.
You're correct. It is. So our answer is 2, 1. That's where they're going to intersect. Number 5. Now, this one says also solve specifically using substitution, although I'm going to let you decide. So I'm going to scratch that out. Some of you may decide, yeah, I'll go ahead and use substitution. And some of you might say, I'd rather use elimination. So I'm going to give you
Blair Merriweather, you have something in the office.
a 60-second head start to use whatever method you want. That way you're not just copying me down, and I don't want to be the one making the decisions for you on your test. So I'll let you decide whether or not you want to use substitution or elimination. And then we can chat about which one you think was better. They're probably both the same, to be honest. More seconds. And I'll try to catch up with you. For those of you using substitution, the easiest variable in the easiest equation that you can solve for is the y variable in the top equation. If you move the 3x over to the other side, it becomes y equals -3x plus 5. And then you can substitute y equals -3x plus 5 into the bottom equation. Here is a common mistake I'm seeing some of you make with substitution. Some of you think that in order to use substitution, I have to get them both solved for y or both solved for x. That is not true. Only one equation needs to be solved for y or x. Pick a variable. Once you have it, you just simply plug it in to wherever the y is on that second equation. You do not need to get both of them in slope-intercept form and then try to set them equal. Then you could, that works. It could be extra work for you though. Riley?
elimination, right?
Okay, go ahead.
So I multiplied the top equation by 5 and the bottom equation by -3.
Okay, And
And
that-
I got 15x plus 5y equals 25 and negative 15x plus 12y equals 9.
yes. Yep. I would have actually gone a different way.
Yes.
Instead of multiplying, hang on. Instead of multiplying both equations by a different number, that's extra work. If you would have just multiplied the top equation by 4, instead of getting the x's to line up, the y's would line up, and then it just saves you a little bit extra time. But you could do that, and you could eliminate the x's, and that's fine, Riley, okay? And that's why you guys keep raising your hand when I go over a problem, you're like, but I did it this way. There's like 18 different ways you could do this. You could substitute it differently than I did. You could eliminate it differently than I did. Okay, just find a way that works. If you times this by 4, you'd get 12x plus 4y equals 20. Don't forget you have to multiply the 5 by 4 on the other side. And then the bottom equation remains unchanged. You wouldn't have to change it at all. And you could add and eliminate your y variables. You get 17x equals 17. Yep. Plug it into the top equation. 3 plus what gives me 5? 2. If you did substitution, you would have plugged that negative 3x plus 5 in for the y on the bottom here. Distributed the negative 4 to get 12x. Distribute the negative 4 again to get negative 20. Combine your x's. Move the 20 over to the other side. Oh, why did I put an x over there? And then you also get that answer. So yeah, I think elimination probably saves you a little bit of time here, depending on what route you want to go with. Cooper.
On both sides, you have to add 5x and 12x.
To get the 17x? Yeah, regardless of which one you, yeah, you're right. Olivia?
You can actually pencil that.
Yep, right up there. They're all sharpened already. Number 6 says solve using elimination, and that's exactly how I want you to solve it, using elimination. Because the x variables are already set to go here. I told you that I prefer them to be opposites, so we add. Adding with negatives has always been easier for me than subtracting with negatives. If that's not a problem you have, then if it says 4x and 4x, you're ready to go. You can just subtract. It's okay if you want to subtract. Here, though, you want to add because they're already opposites. And if they're the same, you can just times by -1. You could always make them opposites. If you don't like subtracting, you make them opposites and add. But here we already have opposites, and we're going to end up with 6y equals negative 36. When you combine a negative 12 with a negative 24, it becomes negative 36. And Kate, Camden, what is our answer for y then?
Y equals -6.
Got it. For the x variable then, I don't think there's really a difference in these too much. Maybe do the top or bottom one because it's got more positives. If we plug -6 in for y, we get 4x plus 8 times -6 is actually negative 48. I'll just go ahead and do that part. And we get that equation that we solve for x. Jace, what happens when you move that negative 48 over to the other side?
It equals 72.
Nope. Negative 24 plus
Oh, negative.
40.
Wait, no. 20.
24. Okay, and then divide by 4 and you get, good. So 6 comma -6. Make sure you're using parentheses for your ordered pairs. Number 7, skip. We don't have time. Number 8. Another one that just says solve. Pick away. 60 seconds, go. Your choice. Cook's choice. That was always my favorite lunch when it said Cook's choice on the menu. I'm like, I don't want no Cook's choice. Give me Salisbury steak. Yes.
Oh, so we're not gonna do number 7.
Nope, just skip it. Bit of a time crunch here. The goal was to practice, not to overwhelm. I'm not going to give you the same type of problem over and over again. We practice substitution, we practice elimination. This one you get to choose on your own. Hello? 10 after? Okay. Sounds good. Down to the cafeteria again. All right. Bye.
How many questions are there?
It's supposed to be 20, but I've already cut some of them out. So we're probably only going to do like 5 or 6 more. That's why I didn't post this on Big Ideas, because people were going to freak out after we skipped ones, like, because they didn't know, what do I type in? So I didn't post it on Big Ideas. We're just doing it in class. Raise your hand if you did substitution. Raise your hand if you did elimination. Raise your hand if you didn't raise your hand. Something's wrong there. Okay. Because I know you didn't graph it. So you did one of those 2 methods. If you did substitution, your easiest method is to go ahead and divide everything by 4 here to get x by itself. That's going to give you -3/4 or -0.75x. I'm not graphing this, so I don't need to write it as a fraction. And then -2.5. Then you would simply plug that in for the x right there. Could do that. If you chose to do elimination, I would have rewrote it first, obviously, put the 3y on the other side. And then I would have times the top equation by 2, trying to line up the y's here, because 6 is my first common multiple. You could also line up the x's, and they line up at 36, but the y's line up at 6. And then times the bottom equation by -3. Why negative? Because I like opposites. I like to add. And that would give you 8x plus 6y equals -20. And -12, no, that's not, that's, okay, sorry, -27. Thought that was a 4 for a second. -27x minus 6y equals -18. And then I could eliminate my y's and get -19x. Yikes, is that right? Equals, oh, that works. Because x is just 2 then.
Is the 9x plus 2y the original question?
Yes. Yeah.
The substitution one that's 0.75.
Yeah.
You put X.
Sorry. Thank you. Thank you. That should be a y.
That's what they mean.
Dang it, my equation is.
Thank you.
That's a Y.
Thank you. Yeah, Olivia?
I got x equals 7.
What method did you try to use?
I used substitution and I substituted to, I transitioned the first problem to the one you had.
Okay, I don't know what that is, so I'm going to have to use my calculator. -0.75 times 9 is -6.75. Why?
Well, I got y equals first, and then I went and got,
What did you want? What did you want?
I got y equals 6.
Oh, yeah, that's wrong.
Okay.
No, it's negative.
Well, I don't even know what y is right now.
It's negative.
So combine your combine your y's, you get -4.75 y. Add the 22.5 to the other side, that's 28.5.
When you divide them, you get y equals 6. Oh, it should be -6.
And it should be negative, yeah. And that, as terrible as that looks, actually just gives you our answer. So I think elimination, just because of the fact of the decimals, I think elimination is probably your better way here. You'll end up getting 2 for x first, and then you'll get -6 for y. If you do substitution, you get -6 first, and then you'll get +2 for y. Yes, Cooper?
I did something completely wrong, and I don't know what I did wrong.
Okay, well, why don't you circle that one and maybe we could look at it after class.
Okay, so would I just put the answers down for?
Yep, go ahead and just do that. Caleb?
So is the answer to have a -6?
Yes.
Yes, I did.
Because I didn't pick it up here, but if I would have plugged that 2 in right there,
You get a-
that would give me 8. I would add 10 to get 18. Divide by -3 is -6. Hey,
So I was doing substitution and I plugged in, the x for 4x equals -3y minus 10.
mhm.
And I got -3y minus 10 equals -3y minus 10.
Okay, so when you do substitute, you cannot plug this into the x from the equation you just changed.
That's what
It has to get plugged into the other. You have to use both. So if you change this equation, it's got to get plugged into the opposite equation, okay? Otherwise, that's exactly what's going to happen. It's going to say this equals that, and you're like,
I was like,
where'd I go? Yeah. Yeah. All right, number 9. I don't know if we have time for this one. You solve a system of 2 linear equations by substitution. Your work results in a third equation, which leads you to, which leads you to conclude that the system has infinitely many solutions. Which of the following could that third equation be? Let's say I do substitution and I get this. Which of these tells me my answer is infinitely many solutions, Levi?
5 equals 5.
Good. You just need to write that for number 9. Write 5 equals 5 and then write infinitely many solutions. Or just many solutions. Also, I'll take that. Number 10, without solving, so just save us some time, match the system of linear equations on the left with the number of solutions it has on the right. To do this, they're all in slope intercept. Well, not quite. Let's go ahead and this would be y equals, Ashton?
7x minus 4.
Okay, so now that they're all in slope intercept form, same slopes? Okay, then something's off, right? Something's special, we'll call it special. Same y-intercepts. No, so this one is no solution. They will be, you can just put no sol for the first part.
Last one is.
Okay. Remember, if they have same slopes and different y-intercepts, that means they're parallel lines. They'll never cross.
So could I just put like 1, no solution?
Sure, A, B, C, okay, 1, 2, 3, sure. Second one, same slopes? No, they'll cross somewhere then. I'm not going to take the time to tell you where they cross, but they will cross somewhere. And then the next one, same slopes? So it's special, same y-intercepts, same line, all solutions, infinitely many or just many solutions. By the way, that is a question you will have on your test Tuesday. It'll say without solving, tell me how many solutions this has. Sure, it's way too much. You have very little space on your paper to do it though, because you shouldn't have to. You should be able to look at it and tell. Number 11, a line with a positive slope intersects a horizontal line 3 units below the x-axis. Select each point that cannot be an intersection of the two lines. So here's what we know. A positively sloped line. So here's my there's my coordinate plane, there's my x-axis, there's my y-axis. A positively sloped line intersects a horizontal line, we'll do this one purple, 3 units below the y-axis. So it has to intersect right there. Just doing a quick sketch here. Select each point that cannot be. So let's first identify the ones that would be. If it intersects right there, what's the y coordinate right there?
-3.
Only one of them. Only one of them has, so we scroll that out because that would be an intersection, but it clearly says cannot be an intersection. -3, 2. -3 on the x2. Well, that wouldn't make sense. It'd have to be a negative slope to cross down here, wouldn't it? Actually, wait, no, because it could cross there. Yeah, I think that's the only one that doesn't work. So I guess you would just select the other three options. It didn't say it intersects at that spot. I guess I was thinking about it wrong. It just said it intersected somewhere on that purple line.
Wait, select each
So-
point that cannot be an intersection.
Yes,
You just wanna
So when you do,
yeah,
Just find stuff that's not a lot.
just write the other 3 points.
wait, so all those work or don't work?
Or don't.
Don't work, but that's what our answer wants us to find.
Like they don't.
They want us to find the ones that don't work. Nope.
I'm just gonna write A, C, B.
Fine.
A, C, B.
Number 13, we skipped 12. Number 13, not even a number 12 on here. Select each value of A for which you can solve the system by elimination without multiplying first. Okay, so what it says without multiplying first, it means you're ready for addition, subtraction right away. What would the A value be in order for me to be able to add right away? -2. So write -2 down. And let's say I was feeling risky and I wanted to subtract them. What could A be? 2. If A is any other one of these numbers, I would have to do some sort of multiplication or division first to try to get them to line up. Okay, make sense? Okay, so 13 is 2 or -2. Number 14, classify each system of equations by numbering the solutions. In each system, A, B, and C, and D are just unique rational numbers. Okay, so I want you on your paper to put 1, 2, 3, 4 underneath number 14. And then we'll either write 1, no, or many. Okay, so let's look at number 1. Are the slopes the same? Yeah, it's kind of tricky because it gives you letters, but they are the same, so they're special. Are the y-intercepts the same? So no solution, they will be parallel. So put no sol for number 1. Number 2. Now, this is not in slope-intercept form. This would be y equals divide by 2, divide by 2, divide by 2. Same slope and same y-intercept. What's this one? All solution or many. I'll put many. I got you in the bad habit of putting all solution, which works for our equations chapter, but not our systems of equations chapter. Number 3, same slopes? Nope. So it's going to be 1 solution. It'll have an answer. We just don't know where yet. And number 4, same slopes? Nope. So it'll also have an answer, and we just don't know what it is yet. Number 15. The cost in dollars for the fuel and maintenance of a go-kart is given by C equals 10x plus 1,200. $1,200 probably to buy the go-kart, and then $10 for every, what does X stand for? Rides? $10 for every ride and gas. That's a lot of gas. Okay. It costs $40 per ride. If he's running the business, he's already bought the go-kart, he's fueling it, he's charging $40 to ride it. He wants to know what the break-even point is. I want to do this one because we've had some questions about break-even. Remember, the break-even point is when the cost equals the revenue. So we have our cost equation. What's our revenue equation? 40x. You're making $40 per ride. And so to find the break-even point, I want to find when R equals C. So I want to set those equations equal. 40x equals 10x plus 1,200. Harrison, when I move the 10x over to the side, what's that give me? Okay, and what's 1,200 divided by 30? All right. So after 40, and what did X stand for? The number of rides. So after I do 40 rides on this, I will have broke even and I'll start making money and be out of debt. Number 16, we're only going to write the system of equations. We're not solving it, but I want to practice a story problem here. There's a total of 68 students in the robotics club and science club. R for robotics club, S for science club. The science club has 10 more students than the robotics club. How many students are in the science club? We're not even going to solve. We're just going to write the equations. What's one of them, AJ? Good job. From that first sentence, we know there's a total of 68 students. So R plus S, 68. Okay. Yes. Okay. Max, what's the other one?
S is equal to R plus 10.
Nice job. The science club has 10 more than the robotics club. Now, would you use substitution or elimination here? I'd use substitution, it's already plugged in, but you could move the R and make it a negative R, and then you could eliminate. So you could do either one.
That would make it easier because you get like.
No, the S is the same. Here's another one. Just need the system. Don't need to solve it. Did everyone get number 17? Oh, 16, sorry, 16, we're skipping 17. Number 18, I'll zoom in a little bit so you can see a little better.
Wait, do we have to solve this?
Nope,
Did we?
just writing it down.
Oh,
Number 18, you and your friend are selling tickets to a charity event. You sell 7 adult tickets. So we're gonna let A be the cost of an adult ticket. We're gonna let S be the cost of a student ticket. You sell 7 adults and 16 student tickets for $120. Your friend sells 13 adult tickets for 9 and 9 student tickets for $140. What's one of them, Dylan?
Oh,
What's one of the equations gonna be?
A plus S equals 120. Is that right?
But it says you sold 7 adult tickets and you sold 16 student tickets.
7A plus 16S equals 120.
Okay. And the next one, Caleb.
13A plus 9S equals 140.
Yep. Would you use substitution or elimination for this one? I would. And it's not even set up for elimination yet, but I feel like it's just going to be easier than using substitution. You could find a common denominator between 7 and 13 or 16 and 9, and then eventually get your answer.
16 and 9, I think is 30.
We'll do the last one real quick. Number 20, there is no number 19, it's just number 20. You rent 3 DVDs, so 3D, and 2 video games, 2D, for $19. The following week, your friend rents 6 DVDs and 4 video games for $38.
Yeah.
It says, which of the following statements can apply? Well, in order to apply it, I'm going to have to try to eliminate something here. I noticed that if I times the top equation by 2,
Everything.
Not only do the D variables line up,
-2.
sorry, -2, if you want to do -2. Everything's the exact same. So when I add, slash, subtract, however you want to do it, I'm going to get 0 equals 0. And what kind of answer would that give me? Infinitely many. Yeah, infinite. I'm just gonna put many. I'm losing my brain's lost some cells today, and I can't spell infinitely. Many solutions. So one of them says many solutions. I'm not sure which one it is, so I don't care. Just put many solutions. Here's what that means. There's an infinite number of video games and DVDs that would fit that description. So, okay. Use the restroom. Use the restroom. And then I want you to come back here and we'll get ready to head down to the cafeteria to hand out some lead awards. Oh, yes, yeah. Take your papers. Bring your papers up to me. Turn in your papers first. We're going to, yeah.
Do we get our stuff?
Yeah, go ahead, get your stuff and head back over here. Get your backpack, get everything you need and head back to my room. Yes, use the restroom, pack your bag. Kiss your girlfriend goodbye. Head back to my room. Oh, nice. Nice. Thank you. Thank you. Thank you. Thank you. Thanks, Harrison.
How did he get my shoe back on?
Caitlin and Caroline and Levi. Thank you.
I would recommend putting a shoe on.
Yeah, we're trying to do that.
Haley, you look better. Yeah, thank you.
Oh my God, my shoe ain't going back on.
Excuse me. Bring your backpacks back in here.
I didn't